Next up, we're going to have Robert, who is responsible for really our HPC strategy for DDN, go through some updates on the product portfolio.
Thanks, Molly. Of course, I had to promise that I don't talk about Lustre, so I will not. Where's Jeff? No, I'll be really, really short. I just want to reinforce a few things in what Alex has been saying. So if we look at the HPC data center today, there is the main compute cluster. There is now something like Hadoop or Spark, similar applications. There may be OpenStack, VMware. And I think really what the requirement that we see at many customers are today is to connect all those things to some sort of storage environment. So typically this was a parallel file system. So we have a parallel file system queue. Now we have added to that the IME queue, and sure, today the parallel file system is GPFS, not Lustre. So we've added the IME queue to that as an acceleration mechanism. Now, of course, we also want to connect those storage pools to Hadoop, Spark, OpenStack. We want to connect the IME world to that. All of that needs to be integrated with a scheduler, an overall management system. Very often there is some sort of scale-out NAS component, you know, your home environment or an environment that connects your compute cluster to your users and the workstations of your users, and, you know, many, many more errors. And the protocols here are IME, no Lustre, GPFS, NFS, CIFS, Hadoop, S3, Swift, whatever it is. And then there is, in almost all cases today, there is some sort of archive backend that in our world increasingly is an object archive with interfaces like S3, Swift. There may be an HSM-like mechanism, there may be more an archive mechanism, there may be a backup mechanism, and there may be replication of data. And then, as I said, there is management monitoring for all of these environments. And this is really what we build today in many cases, and what the way to build it we want to simplify in the future. Now, you know, if I think about drives, I'm sure that if somebody had asked me half a year ago, sort of, SSDs in HPC, I've said, no, it's, you know, sequential workloads. But if you look at the storage market overall, this is an area where the HPC market is really getting a bit behind, because the enterprise storage market today is mostly flash-based. And thinking, sort of we, DDN, you know, we pride ourselves to be the leading company in HPC, and we sell an exabyte of drives every 2-3 quarters. So I guarantee you that in 10-15 years we'll look back and say, did we really put data on these things, you know, spindles? And, but so we still use drives. We still sell a lot of drives. But clearly the future direction in performance storage is not drives. And we have made decisions a few years ago to go in a direction that is really, really different, and Alex already talked about that. We have talked for 2-3 years now about the burst buffer component as a component that accelerates a parallel file system. We have added to that a more classical block storage component on SSDs that we call flash scaler, and it's a lot more than just painting a box in black and say this is flash. This is actually a project that started a few years ago, and when we looked at the SFA architecture and we thought, you know, what can we do with that architecture if the device is no more a drive that does 100 IOPS, but the device is an SSD that does 100,000 IOPS. And we found out very quickly that if we just used a few more cores for the SFA architecture, we could do, even in a 12K system, 4 or 5 million read IOPS from those devices, not from cache. So we finally, and we started to sell these systems actually 1 or 2 years ago in an experimental fashion. And the few systems we sold have been a real success for us. So we said, okay, we need to bring this to a broader market. And this is really what this additional layer is. So this is not your classical flash storage, but it's really performance flash storage that comes in a small form factor. And that we want to use not just in the classical way of the block RAID array, but in things like file system and accelerated file systems. So the 4U box can be a rack full of flash, or it can be a 4U box with SSDs, with drives in the back end. And this will be really the future for a few years. So yes, your performance storage will be on flash or flash-like devices, even in HPC, and your capacity storage will be on drives. The reason for that is simply that drive capacities are going up and up and up. And there is a ratio. A drive has 100 to 150, 200 megabyte per second bandwidth. It has typically 70, 80, 90 IOPS if we talk about the drives we use today. And the reality is that in the customer use cases, the requests for IOPS go up, but we use less drives because the drives have more and more capacity. So really the only way to build performance storage in future is by adding a tier of either cache or a file system pool sitting on flash. I promised to not talk very long, and I promised not to talk about Lustre, but we did introduce finally our ES14K. So I have to talk about that. It's a product I'm very excited about. So it is a Lustre appliance where we see today out of this 4U box almost 40 gigabytes per second if you use flash, or a bit less than that if you use drives. And it really is an exciting new platform for us, where finally that vision that we had a few years ago of virtualizing file system services really has become a reality here. This completes our portfolio from very small to very large, and this is really what DDN is about. So you can choose your building block. You can choose a small building block. You can choose a large building block. And at the end, I'm looking at a customer in the room from Japan where we haven't quite made the announcement in time yet, so I can only announce one system that we have won in Japan, Oakforest-PACS. Is a collaboration with Fujitsu and Intel, where the storage piece is a large Lustre file system, but a large Lustre file system enhanced by a very large IME system. So this is our first very large IME procurement, with about a petabyte of flash, performing anywhere from a terabyte per second to 1.4 terabyte per second.